Let's go ahead and head into Matt's talk.
Hello, Deserted Island DevOps. I'm so sad that I can't be with you there on the island in person this week. Massive FOMO on my part, but I am here virtually nonetheless to talk to you about hands-on Kubernetes deployment security. So my name is Matt Johnson. I'm a DevSecOps advocate with Bridgecrew, now with Palo Alto. In my spare time, technically, I tinker with edge compute. I've been using containers since before they were called containers, and I'm training to be a private pilot. Throughout this, obviously, going to try and kind of get really hands-on, going to show some workshops that you can recreate at home and have a tinker with. Hopefully, this talk convinces you to give them a try and go and have a play with the workshop environments yourself. But any questions, comments, follow-ups, you can reach me at Twitter, or all the rest of the details are at that QR code. So I'm going to leave this up here. I'll put it at the end as well. As I said, we're going to be using some public workshop resources that Bridgecrew have created. We're going to be using our open source scanner Chekhov and a load of other little Kubernetes goodies. So let's get started. So as I said, the idea is to try and get people to think about the infrastructure security and infrastructure as code security requirements that go with a modern automated deployment, such as that we might have with Kubernetes. You're probably going to have some kind of DevOpsy CI/CD pipeline. You're probably going to be reconfiguring your application deployments in an automated way through infrastructure as code. And while all of that brings great convenience, great traceability, all that other good stuff that we love about kind of DevOps, GitOps, pick your favorite buzzword, it also comes with some security practices that need to be considered as well, just like any type of deployment. And so we've created a workshop which hopefully will walk through the different options you have to very easily add layers of security into your environment. And what that looks like is basically step by step, and it's designed to spin you up a known starting point to make it really, really easy for everyone to be on the same page. We're obviously not going to try and do this recorded remotely with you all today, but I kind of want to go through and show you the kind of points and the takeaways from the workshop, and then obviously if you want to go through yourselves, it's all public and you can do. So first of all, I'm going to introduce our little setup. Now we do run kind of proctored workshops every quarter, so if you want to do this on someone else's dime and you do want to have a tinker, by all means please sign up to one of our workshops where we do those in partnership with AWS, and they provide event engine accounts for 24 hours so that people can do these in a completely kind of isolated, hermetically sealed environment away from their own AWS accounts. But what effectively we have is a piece of CloudFormation that will go and spin up a lab environment for us to work with. And the lab environment requires a few items. It requires our code repo, where we actually store our Kubernetes, our manifest for our infrastructure as code, our applications to be deployed. It requires a Bridgecrew API key, as we'll see, because we're going to do some really cool security stuff through Bridgecrew and our open source tool Chekhov. And then also a public IP address, just to try and lock the environment down and make sure that we're not creating public AWS resources. And what that leaves us with is, once the CloudFormation has run, and again, feel free to just watch, don't think you have to do this to get something out of this talk, but what we end up with some outputs that help us work out what we're going to do. So we end up with, that looks like some Argo CD, and we can see that here. I've already run the CloudFormation and set up my environment for this talk. And we also end up with a pre-configured Cloud9 environment, kind of like Amazon's version of VS Code Web, which just can be pre-populated with a shell. You can see we've installed some tools we're going to need here. We can see we've run some back-end automation, so we have a file containing our Argo password. And so we can log into Argo and see where we're at. The idea of this is we are going to be dumped into what is effectively an existing developer's kind of brownfield site. We're not starting from scratch. They've got some stuff in prod deployed, and they've got a development environment that isn't deploying. So let's go and have a quick look around our cluster, shall we? So we can see some, yep, okay, so we see this customized Goat application. And okay, we've got some bridge crew stuff in there. We've got Argo CD itself running in the cluster. Cool. And we see that there is nothing related to customized Goat dev anywhere in our pods. So let's go and have a look at prod first of all. Yep, that's all looking pretty healthy. I see green. That's generally a good thing. Wonderful. Now let's go and have a look at our customized Goat dev. And you can see here we have no deployments at all. We have our load balancer, that's fine, but we don't have any pods. We don't have any application code. Let's see why that sync failed. Okay, so if we look here at, some of you may be familiar with Argo CD or any other kind of continuous deployment tool, this will have tried to give our manifests, which are stored in our customized Goat repo, again, forkable and available for the workshop, which is just a really simple set of customized manifests. You could also do this with Helm or raw Kubernetes manifests if you wanted to, but we were trying to kind of simulate a real world environment where people would probably use something like Kustomize to create slightly different dev, test, and prod environments off a single set of base Kubernetes templates. So as we can see, we've gone in here and we've asked Argo why this failed, and Argo, like other CD tools, is just trying to throw these rendered manifests against the Kubernetes cluster, and the Kubernetes cluster is saying that because of a admission policy, a Chekhov admission controller, we're not letting this into the cluster. So that's great. We clearly have something security related already in our cluster, and that was kind of hinted at by the fact we had these bridge crew validating webhooks here. So yes, we have pre-populated this cluster with the Chekhov, which is an infrastructure as code scanning tool, admission controller. So what that's going to do, it's going to look for the worst of the worst offending issues that can be related to Kubernetes manifests, and Terraform and CloudFormation for that matter, but specifically around Kubernetes in this instance. And we're going to go, okay, we really don't think you should be allowing a root container into this cluster, for example. And then it's going to give us some documentation if we want to read up on that. And it's also going to give us a link so that we can see a slightly prettier view. So if I go here and follow that link, when we span up the CloudFormation, we ain't got a bridge crew API key. That's what has been used here to integrate this. And basically everything we're going to see is layers and layers of security. So this is great. I mean, as a developer, I never really want to have to come into a security tool like this. But what is cool is that with a simple integration in Argo or very bad root containers, for example, one of the many things that you probably want to look at, issue has been blocked, and yet when my computer catches up with the screen share, when it catches up, you will see that a security team or a team central for a lot of different repos or a lot of different projects will also be able to kind of go through and see, okay, well, someone's been trying to add these deployments to the cluster and they've been blocked. So we can get kind of a centralized reporting of all those incidents as well. We'll come back to that in a sec. However, this is, not a particularly nice UX. And also, in terms of security, in terms of, every security person probably always saying to you, defense in depth or security is a journey or all of those wonderful, kind of jokey phrases. It's also not an ideal place to be. If we look at where we are in terms of the developers' in terms of the developer's pipeline, we're here right now. So we've already had the code authored. The code's clearly been committed by someone into a branch. It's gone through some kind of CI/CD. It's gone through some kind of testing. We've either a pull request or tests by the internal team. It's somehow got to the CI/CD tool, which is responsible for talking to the Kubernetes cluster. And it's only at this point that we are currently going, hey, there's something wrong with this. That's probably not ideal. So we're kind of working backwards here. We're in a scenario where it's good. There is some belt and braces security right at the end of the deployment pipeline, but we can do better. We can do better for our developers. The concept of shift left security that we promote is often misunderstood as, oh, well, it's just security is now the developer's problem. That's really not it. We really want to get as close to this end here to kind of make security more obvious, easier, like what am I trying to fix? And also when I do get security errors, I don't want them looking like this deep in a spurious failure within Argo. So what can we do to improve the developer experience while still providing, a secure set of wrappers around our deployment? So the first thing we can do is think about that diagram and step back a little bit. So before we get here, we have all these steps. What else can we do in these steps? And there's lots we can do, and not surprisingly, they all relate to a different integration that you can either do through Bridgecrew's cloud platform if you wanted to do centralized monitoring of these, but a lot of them are powered by our open source tool Chekhov, which is running in the CI pipeline under the hood and actually is the engine that is powering the admission controller as well. So Chekhov is open source. It is an infrastructure as code security scanner, as I've mentioned. It's on GitHub. It's has a load of built-in policies for pretty much every infrastructure as code language you can think of. So your Terraforms, your CloudFormation, your Helm, Kubernetes, Customize, and all of that. And so that's what's kind of powering a lot of these integrations. But we can do a lot when we are able to trigger lambdas and automation and webhooks based on events. So for example, instead of just leaving it at the Argo position, what we can do is we can go and integrate GitHub directly. And what that allows us to do is see the code way before it gets to our CD pipeline. So for example, if we go into projects, I can now just see my customized Goat repo directly, and I can see what issues there are in there, maybe within the Docker file, maybe within, Helm charts, Kubernetes, etc. If we look at a more complex repo, like the external Kubernetes Goat, which contains a lot more intentionally vulnerable Kubernetes vulnerabilities, you can see here we pick up all kinds of things directly from this fork I have on GitHub. So for example, we shouldn't be using a latest version tag. It's open to abuse. You don't really have a knowledge of whether that container has changed. We have no health checks, so the scheduler doesn't know whether that pod has exploded, so it could lead to downtime issues. There's no user for the container, so it's probably running as root, along with loads and loads and loads of other issues that you can prioritize by severity, etc., etc. So that's all well and good, but how does that help the developer? We're still in this kind of security tool, if you will. Another benefit of tying things into GitHub is we can start doing automatic annotations of pull requests, for example. So within a developer environment, you'll actually get some information with checks that are automatically going to be scheduled and be like, hey, this is providing details of you probably shouldn't want to run or merge this pull request because there are some quite a lot of issues in terms of the default configuration of these deployments, and you can see that Chekhov is smart enough to know that this is customize. This is one of the overlays within customize. It's the dev2 overlay. There's also a dev overlay. There's a base deployment which also has issues, so you can see where those issues are coming from in your customize, similar to Helm or basic Kubernetes manifests. So that's all well and good, but again, it's still just advice. One thing that is cool, and I will point out, is for every piece of output in Chekhov, there is a guidance link. And the idea with the guidance link is to provide... Oh, I think I pasted that wrong. Yeah. Don't want to pipe in there. To basically provide a little bit of context to a developer who maybe isn't the security advocate on the team, like why does this matter? Why would allowing this through pose a risk to your cloud infrastructure security posture? And just to provide a little more context on all of the different policies that we have going on in there. So that gets us a little further. We can, click through, and at least that context is within, the developer's day-to-day tools. It's within GitHub or within their other CI/CD pipeline. As you can see from the integrations page, we support most CI/CD tools you can imagine. And again, you can also do that purely with open source Chekhov, should you wish. We have Chekhov examples on chekhov.io for most of these CI systems as well. And so again, really useful, but only as useful as the people kind of looking at the tests running in the pull requests. What if we actually need to mandate a hard stop on our CI pipeline? A lot of times you want your CI and your CD separate, because now supply chain attacks and CI compromises are quite a thing. You don't really want that compromise ending up with the exposed secrets for your production Kubernetes cluster. So you may want to do all the more complex kind of tests, CI stuff in an environment with a bit more lockdown, maybe no access outbound to the internet, and definitely no keys to your cluster, your kingdom. So what we can do here is we can look at, let's actually enforce something earlier in this process. Let's think back to this diagram. Let's think back to this diagram. Okay, let's not be doing it in the pull request, because again, that can be ignored by someone just going, YOLO, looks good to me. Let's actually put it somewhere in the CI before we get to the CD. And again, for this, super easy. We'll report into the dashboard as well if you wanted it to. I have too many tabs open for my own good here. Here we go. And what we can do is we can just have a simple Chekhov workflow that you can, again, using GitHub Actions as an example. It's in the GitHub Actions marketplace, so you can literally click to add to your repo, and that's very simply going to run Chekhov based on your any commits, or in this case it's on all pull requests and any changes to the main branch, but you could configure that to your liking. And also you can configure Chekhov to run certain tests. There's a very large set of configurations in terms of only scanning for certain priorities at different points in the pipelines, different severities, and whether you want it to hard block the pipeline or just alert. So this is getting better. We're moving further and further back down this kind of developer's day-to-day. But it's still not quite the perfect solution, because you really don't want to be in a scenario where you've already done the work, you've already written the Kubernetes manifest, you've already committed, you've already created the pull request. You don't really want it right at the CI to tell you, go back and you're not actually finished. I hate that when very much better developers tell me things on code reviews in pull requests. It's like, I'm glad to be told, but I wish I'd known sooner. And so the final thing to get us right back to here is one of the coolest things, I think, about having these kind of tools, and about how codifying our infrastructure really helps us have a good security posture, because we can have these automations running for us and saving us time and telling us things. And that is our VS Code plugin. So we can see, if you look on the Visual Studio Marketplace, we have Chekhov by Bridge Crew. And VS Code plugin Chekhov does exactly what you might think it does. You open a piece of Kubernetes or Terraform, or Kubernetes in this case, but I will stop repeating that we do many other types of infrastructure as code. And what you're going to get is all the results that the developer is likely going to get in CI. If the Chekhov CI has just been left default to report on everything, you get severities, you get a link to those help pages that I was referring to earlier, and you can see that these issues apply to just this particular app. So we can see there are lots of issues here, some of which higher priority than other, that we should really consider fixing before we deploy this application. And it also lets the developer know that these realistically aren't going to get through CI, so they need looking at or discussing now rather than later. So for example, what we could do is we could change this, for example, to a SHA, so that it's not just a random tag, that if an attacker did have access to the container registry at some point, would be able to put his own code as 0.1, and we're going to blindly pull an unknown amount of code. So again, now we're right at the beginning, and this can also be viewed in a much neater way with view problems, and it integrates into the problems list as well, so we can see them all in one place without having to hover. And there's the image digest should be used as an example, along with not using root containers, which is always a nasty one. So with that said, we're not quite finished. Takeaways in terms of things you can do, definitely go and check out Chekhov, obviously. But there is a part of the puzzle we haven't covered, and that is, what about in your live environment? This all assumes that everything that says it's going to be in Git is exactly how it is in your AWS account, and we know for a fact that that is generally not true. Someone might have gone in for a quick fix at 3 a.m. in the morning when there was a failure, or left some logging on which fills up a disk, or all kinds of things happen, and it's still important to kind of have checks and balances to make sure that the live environment is actually what we think it is. Now, from Argo's perspective, Argo actually does a really good job of doing that drift detection for us for anything that Argo knows about, going, hey, yeah, your Kubernetes cluster is out of sync with what is in Git for these deployments. However, you don't just get born with the Kubernetes cluster. There are probably things in your Kubernetes cluster that are deployed outside of Argo because they're not your apps, maybe things that are needed for cluster monitoring and maintenance, and they can just be as insecure and cause you cloud security posture problems as your app deployments themselves. And also your Kubernetes cluster, unless you're going hardcore and running it on a bunch of Raspberry Pis in someone's garage, is probably going to be on a cloud provider, and they don't just exist in a vacuum. So it's also important to think about, well, what is the default cloud provider's posture when I get a new account with a cloud provider? Are there IAM policies that maybe could be more restrictive than they are? Like, do all of my block volumes have encryption at rest or encrypted launch configuration, or am I kind of exposing some secrets? And so it's important to think about the posture of the whole stack, including other parts of your cloud, because they are all accessible via APIs, just like potentially your Kubernetes cluster. So with that said, I hope I've kind of given you an interesting insight into some of the areas and some of the security boundaries you should be thinking about with cloud managing your Kubernetes deployments and infrastructure as code deployments in general. And if you do want the resources again, I'll put them up there. Please do feel free to check out the workshop or sign up for a proctored workshop where we can give kind of more one-on-one help and answer more questions. Chekhov URL is there, and again, would love to have any more conversations on this. If you're interested in kind of developing this further, or just trying out some of these concepts. Anyway, thank you very much, and enjoy the rest of your time on the island.